this module, we will see how to express the recurring decimals in the form of P upon Q. Now children, you might be remembering that our rational numbers are either terminating or recurring. That means the recurring numbers are rationals. Recall it very nicely. I am repeating the statement. Recurring decimals are rationals. And we know that a rational number is of the form P upon Q. So right now, let me take a few examples. 0.666 repeating, or let me take 0.232323 and so on. Okay, so we'll just see them parallel. Okay, now we want to express this recurring decimal in the form of P upon Q. The solution would remain the standard solution. Now see, first we will assume this to be x. So let x is equal to 0.666 and so on. Right? Now, what we are going to see is that, mark these words, it is an underlined and important word. Immediately after the decimal point, how many digits are repeating? Here, after the decimal point, only 6 is repeating. 1 digit is repeating. In this case, if I would start the solution, how am I going to write? Let x is equal to 0.232323 and so on. How many digits are repeating here? 2 and 3. 2 digits are repeating. Here, single digit is repeating. Because a single digit is repeating, we will multiply by 10. 2 digits are repeating, we will multiply by 100. If 3 digits were repeating, we would have multiplied by 1000. Okay. So as here 1 digit was repeating, only 6, we are going to multiply by 10. Since here 2 digits are repeating, we are going to multiply by 100. Now we'll first complete this part. Parallelly we can do this same type of example. This is going to be, it's very easy. So when I multiply the whole equation by 10, the left hand side as well as right hand side gets multiplied to 10. So 10 into x is equal to 10 into 0.666 and so on. And mind well, the first, when x is equal, when we assume the given number as x, it always becomes our equation number 1. Now here, this is what we have studied last year in exponents. When we multiply by 10, the decimal point shifts towards right. We are multiplying by 1 0, decimal point will shift by 1 place. If you would have multiplied by 10 raised to the power 2, that is 100, 2 zeros, decimal would have shifted 2 places. So right now, the decimal point shifts 1 place and 10 into x becomes 10x is equal to, decimal point shifts 1 place, 6 point, this 666 and so on remains as it is, and this becomes our equation number 2. And simple. Here what are we going to do now? Subtracting equation 1 from equation 2. Let us do it very quickly. Yes, we get here, we are going to subtract. So left hand side minus left hand side is equal to right hand side minus right hand side. We will just write it in vertical. Okay, because we know we can either subtract horizontally or vertically. This time the vertical subtraction becomes easy to understand. So let me write. This is our first equation. Second equation is 10x is equal to 6.666 and so on. Minus x is equal to 0.666 and so on. 10x minus x, left hand side, like terms, we can subtract them. 10x minus x, 9x. 0.66666, 0.66666, will it get cancelled? Yes or no? And 6 minus 0 gives me 6. This is 9 is multiplied, goes there and becomes divide. X is equal to 6 upon 9. That is P upon Q, where P and Q both are the integers. Q is not equal to 0. Did we get P upon Q form? And you can definitely check. You divide 6 by 9. Very quickly I'll show it over here before we move to the second example. 6 when I divide by 9. 9 cannot divide 6. 9 zeros are 0. 6 we get a decimal point. Introduce a 0. 9 6 are 54. Remainder is 6. Get a 0. 9 6 are 54. Remainder is 6. Get a 0. 9 6 are 54. Remainder 6. It goes on continuing. Do you get? 6 divided by 9, 0.666. This was our question. If I would have told you find out the decimal expansion of 6 divided by 9, you would have divided 6 by 9 to get the answer as 0.666 and so on. Now, just the reverse. I have given you the answer. 0.666 is the answer of what? The answer of 6 upon 9. Am I right? Very quickly we will solve the same example. You can do it on your own. Right now on the screen you can see it. We have already solved this example as it was multiplied by 100. So it would have become 100x. Decimal point shifted 2 places. Let us see what happens over here. So that's what we have seen over here. Multiplying by 100, decimal point shifts 2 places. So what do we get? 23.232323. And then subtracting 100x minus x, 99x. 0.23, 0.23, 0.23, 0.23, 0.23, 0.23 gets cancelled. 23 minus 0 is 23. X becomes 23 upon 99. Integer upon integer, P upon Q, rational number. And if you want to see here, single digit was repeating. A hint I am giving to you. 6, only one digit was repeating. We got 6 upon 9. 2 digits are repeating. So what did we get the answer? 23 upon 9 and 9. 2 9s we have got over here. 23 upon 99. Similarly, now if I would have asked you, now, dear, if it would have been a 3 digit repeating, for example, let me write here 0.117, 117, 117 and so on. Then what would be its P upon Q form? Now you can tell me 3 digits are repeating. We would have multiplied by 1000, done the same procedure, and what we would have got finally? X is equal to 117. 3 digits are repeating. You get 3 9s. 117 upon 999. And dear children, this form of decimals, wherein, very important point, I want to write it down, wherein immediately after the decimal point certain digits recur. Here immediately after the decimal point 6 is recurring. Immediately after the decimal point 23, 2 digits are repeating. Immediately after the decimal point 3 digits are repeating. This form is called as pure form of decimal numbers, and for pure form 1 digit repeating, the digit divided by 1 9. 2 digits repeating, 2 digits divided by 2 9s. 3 digits repeating, 3 digits divided by 3 9. So that's all about this pure form. There is one more form. For example, suppose if, let me write it over here itself. Suppose if I would have got, say, a number which is not of pure form, 0. Or let me say, yes, let it be 0.1222 and so on. So after decimal point the digit is 1, which is not recurring. This little bit of changes, but that we'll see in our next video. For this video, we have dealt with the pure form, that is immediately after the decimal point, the digits recur, and that's how we get the P upon Q form. That's all for this module. Thank you.